So I will present in part 4. This is the first problem of this year's IMO.
And the first part of the problem.
Yes, this is one part of the problem. So we want to find infinite many ends where there exist an endpoint sets are balanced center free as we defined in the previous video. So first of all, let's do some English and look at what these two words actually mean. So first of all, if it's balanced, then which means it's like probably symmetric in some way, because as we said, like if I have 2 points, we must have like another point that's equidistant on both. And the center free means that like there's like not really a point in the center. So which means that all points can scatter around a circle. So given these two definitions, it kind of inspire us like to think about regular polygons. So in the previous episode, we talked about when n equals 3, this n-equal triangle works. When n equals 4, it's a square, but we can easily see that these 2 points don't have like another point that's equidistant on both, so it doesn't really work. We can try this out, but it probably doesn't work. When n equals 5, we look at regular pentagon, and this is a little bit difficult to see, but if we look at these two sides that are, say, parallel to this axis, we have this point that is equidistant to this point and equidistant to these 2 points. And we can count rotate this by 72 degrees and do the argument for these two sides, etc. So this works. And so if we go to n equals 6, we can see that the same thing happens with the side because really there's no point on this line that works. So it kind of hints that like, we should think about all plans. And when we n equals 7, we have a regular pentagon, which also works. So here's like the simple idea of why every odd number sided regular polygon works. So let's just take, say, heptagon, for example.
So clearly it's center free, right?
Yes, yeah, because like you take any if you take any 3 points,
The center is missing.
Yeah.
They're all
because any 3 points have a center, have a circle center, which is not here. So we don't need to worry about center free. We only care about if it's balanced. So if we look at one segment like this, we consider we either have to look at this side or this side. So apparently only one side has an odd number of points. Exactly one side has an odd number of points.
That's where you use the parity, right?
Yes. So if one side has an odd number of points, which means that there must be like a point in the middle of the arc, which because this point is in the middle of this arc, and therefore it's equidistant to these 2 points. So which means for any diagonal sides, we have 1 point on like this equidistant to both endpoints. So since all end works, we claim that we find infinite many ends that